Welcome to ratio unit conversions. The order in which you multiply numbers doesn't matter. So if we have something like 2 times 4 times 6, that equals 48, but that's also equal to 6 times 4 times 2, or 4 times 2 times 6, or 6 times 2 times 4, or 4 times 6 times 2. Doesn't matter which order we have the numbers in, the result is always going to be the same for multiplication. And this means that it's also true if you're multiplying units together. So if we have something like 12 meters per second multiplied by 60 seconds per minute times 60 minutes per hour times 1 kilometer per 1,000 meters times 0.621 miles per kilometer, that gives us 27 miles per hour. So we know that 12 meters per second is equal to 27 miles per hour. And the meters is canceling here, even though they're not adjacent. So our meters there is canceling with meters here. They don't have to be right next to each other because it doesn't matter the order that we put our units in. So if we write a quantity like 12 meters, the unit is meters, and this is a single unit. A single unit is a unit that has a unit in the numerator, but no unit in the denominator. So on the last slide, we have here meters divided by seconds. That's not a single unit. That is what we call a ratio unit. But this, 12 meters, that is a single unit. So this means that the fraction involving the units for a single unit is whatever our unit is divided by 1, because anything divided by 1 is itself. So in that case, 12 meters gives us 12 meters over 1. So meters, grams, seconds, meters, cubic centimeters, gallons, these are all single units. But we also have ratio units, which are a ratio of 2 different units. And here are some examples of ratio units. Meters per second, m/s, that's still meters per second. Meters times seconds to the minus 1, that's again still meters per second. And when we're working with ratio units in a conversion calculation, we want to write the ratio unit in a fraction form. So we're going to write all of the above, so all of the 3 examples that I had on the last slide involving meters and seconds, we want to write those as meters divided by seconds. We want to write it as a fraction like this, because that gives us a numerator and denominator that we can work with. We're going to discuss ratio units more in chapter 11, but we can still use them some here in conversion factors and work with them. So thus far, our conversion problems have started with a single unit, and we've multiplied the given single unit by a fraction, our conversion factor, with the given unit in our denominator. But if we need to convert a unit in the numerator of a ratio unit, we follow the same steps. But if we need to convert a unit in the denominator of a ratio unit, we need to make a small change to what we've already discussed. If a unit to the right of the equal sign, whether in or after the given, whether on top or the bottom, matches a unit in the answer unit, so in both what it is and where it is, so numerator, denominator, whatever, then we want to circle that unit on the right side and don't convert it any farther. If a unit to the right of the equal sign, whether in or after the given, whether on top or on the bottom, is not what we want, then we want to put it where it will cancel and convert it till it matches what we do want. So if the unwanted unit is on the top, then putting it on the bottom of a conversion factor will cancel it. If the unwanted unit is on the bottom in a denominator, then we want to put it on the top, and that will the top of a conversion factor, and that will cancel. So let's look at our example again. We have 12 meters per second. We multiply by a few conversion factors to get our answer here. Note that our meters is in the numerator of our given, and that's canceling with the meters in the denominator of one of our conversion factors, the third conversion factor. The seconds in the denominator of our given is canceling with the numerator of our first conversion factor. So that's the seconds here. So if we have a unit on the bottom in our given that we want to cancel, we need to put it on the top of a conversion factor. It doesn't have to be the first conversion factor, it could be over here somewhere. And if we have a unit on the top of our given that we want to cancel, we need to put it on the bottom of some other conversion factor, and that's what we've done there. So, many different problems will require you to convert both the numerator and denominator of a ratio unit, and the order that you convert in doesn't matter. In other words, converting the numerator or denominator first makes no difference. Just pick one, whichever one you want. So, for example, these two calculations are equivalent because the order of multiplication doesn't matter. So we can either convert 12 meters per second to 27 miles per hour by getting rid of seconds first, getting to minutes, and then getting rid of minutes and going to hours, and then converting our distance units. So we can either convert our time units and then distance units, or we can convert our distance units and then time units. Doesn't matter which order we do it in, we're going to get the same result, and you can see that we do end up with the same answer for each of these. So that was ratio unit conversions.